Alright, calculator folks, I'll first start by saying I recommend you watch the other non-calculator version of this video. It discusses things in a lot more detail that I think is important for you. But if I covered it in this video, it would make the video longer than the other one because I'd be saying the same exact thing in that video again, but with the addition of showing you how to do things in the calculator as well. So I'm just going to resort to just the calculator in this video, but a lot of these problems make a lot more sense, knowing kind of the ins and outs behind it, which I discussed in the other video. So if you're up to it, I would recommend watching that either instead of this or in addition to this. All right? But we'll still talk about some of the main things that you can use the calculator for here. All right? So let's go ahead and begin. Number one, you don't need your graph calculator with. It's just asking you, given this top graph here, which transformation best describes the graph below? So if it started here on top and now it's transformed into this one, how did it move? Did it shift down to, did it shift right to, up to, or left to? Now let's point out a few things. Let's point out here there's a y-intercept at 1, and on this one, the y-intercept is at -1. That doesn't necessarily mean too much, but let's also notice that here on top, the bottom of this arch sort of levels off at 0, whereas in the bottom one, it sort of levels off at -2. So everything about this seems to be the fact that it's been shifted down 2. So you're just kind of looking at the graph and seeing how it's moved from where it was on the top to where it is now in the bottom graph. And it's clear from this one that that shift was moving downwards too. All right, so let's go ahead and use a calculator. Let me go ahead and also write what this means in terms of how you plug this into your calculator. The original line, if the slope of y equals 2x plus 5 is changed, so we have y equals 2x plus 5. But if we change the slope to -2, how does the graph change? Which means if we make we change it to -2x plus 5. Remember, y equals mx plus b is our slope-intercept form, so we're changing the slope from 2 to -2. This is what it would look like here. So it's 2x plus 5 originally, but you're changing the slope to -2, so now it's -2x plus 5. We can just graph those two lines in our calculator and see how they've changed. So let's go to let's quit this, go to your y equals, and we can type in those two equations and simply look to see how it's changed. So the first one was 2x plus 5, and the next one was -2x plus 5. So let's see what happens. Let's graph it. Hopefully my window is set properly. All right, so there's the 2x plus 5, and now here comes the -2x plus 5. All right, so let's look at our answer choices and see which one best describes what happens here. So the graph is more vertical. I would disagree with that because it looks like the slant's almost the same, except in the other direction. So the graph does not change. Well, that's definitely not true. It definitely changed. The graph is more horizontal. That's not true either because, like I said, the slope is roughly the same, just in the opposite direction. So, there you go. Option 4. The graph slants in the opposite direction. It's pretty obvious. That is definitely the correct answer here. All right. So which statement describes how the graph of this, y equals x plus 5 squared minus 2, and the graph of y equals x squared differs from the graph of y equals x squared? So let's just put those two in our calculator and then let's look at them to see how they've moved or how they've changed. Let's go ahead and put the basic one in first. So let's go ahead and start with the x squared in here first. X squared, and then what was the other one again? X plus 5 squared plus 2. Notice the parentheses. Keep that in mind. We'll have this x plus 5 in here, the parentheses. We'll go ahead and square that. And then was it plus 2? Or was it minus 2? Okay, cool. Minus 2. So definitely worth double checking. Make sure you type that in properly. That's going to make a big difference. Let's go ahead and graph it. Let's see what the difference is. So here's y equals x squared. It's a standard parabola at 0, 0. And here's the other parabola. All right, so it doesn't look like it's any wider. It looks like it's the same width. So it's not 1. It's not narrower, like it's at the same width. Let's see, but it's been moved, of course. Was it moved 5 units left and 2 units down, or was it moved 5 units right and 2 units down? Well, from 0, 0, let's go ahead and move the annotate this a bit. This is where it started. This is where it ended. It definitely moved to the left 5 and then down 2. Alright, so just using that information, it's going to be what? Option 3? 5 units left, 2 units down? Definitely option 3. Alright, same thing. Let's just go ahead and type these in the calculator and see how they're different. We have x cubed is transformed into x minus 3 cubed, and how are they different? So let's go back to our y equals. Let's clear out what's here. Alright, now to type in x cubed, you type in x and then the little caret button thing to the third power. And then the other one, we have to do these in parentheses, remember. So this will be parentheses x minus 3. It was minus 3, correct? That's one double check. Yes. Minus 3, close parentheses, and then raise that to the third power. Alright, so let's go ahead and graph those. Oops, graph. And we'll see what's different. So here's the original one. Again, the middle is right at 0, 0, which is the thing to really pay attention to. And then here's the other one. Alright, so it looks like it just moved to the right 3. So is there an option that says that? You betcha. Alright, so graphing it, you can visually see how it's changed. But the thing is, when you graph it, you do have to remember which one is the original one, which one's the most basic. And usually the original one's at 0, 0. So tend to start from 0, 0 and then see how the other one moved away from 0, 0. Alright, we're going to repeat this process one more time, maybe even a couple more times, who knows. But how will the graph of the square root of x change when the function is changed to the square root of x plus 2? Be very mindful, by the way, I'm going to use my pen here, that this plus 2 is inside the radical. It's not square root of x plus 2, it's square root of x plus 2. Alright, there's a big difference between the two being outside the radical and the two being inside the radical. So let's keep that in mind when we type this in our calculator. So go to calculator, back to this, clear that out. And we have, Jesus, what was it again? Square root of x. Alright, cool. So the square root, so that's shift, and then that button will get me my square root of x. Let's go ahead and leave that alone, and then we'll put the x plus 2 next to it. So watch carefully what I do here. I'm going to go ahead and hit my square root button, but then I'm going to hit x. Now notice I'm still inside my radical, which is where I want to be. If I hit the arrow to the right, I'm going to get out of my radical. I don't know if you saw the difference, but it's a big difference. See, I'm inside the radical still, and now I'm outside the radical. So arrowing left and right kind of make that change. So I'm inside the radical, I want to be, right? X plus 2. We've already mentioned that. I want that plus 2 to be on the inside. The big difference, doesn't matter. Let's go ahead and graph it. So here's the original function again. And there's a new one. So it moved to the left 2 units. Is there an option that says that? Yes, there is. Okay? Alright. There's a couple things you could do here. We can graph the y equals x, right? We want to see which one, if we translate it up 6 units, what would the equation be? What we can do is just try these out individually. I will say we should probably just rule out option 1 and 2 immediately, since they are x equals. It's a little bit different than using our calculator where we have the y equals, right? So it's either going to be, I want to clear these, the third option or the fourth option. So let's just plug those in our calculator to see which it is. I'm looking for the one that moves it up to 6. So the original one is y equals x. So let's just, y equals x is our first equation. The next one, let's try the x plus 6 first. So x plus 6. Let's go ahead and graph it and see if it moves up 6 or how it moves. So here it is right now, it's at 2, 0. And here's a new one. It's definitely been moved up 6, so that seems to be the correct answer. Just for fun, let's type in x minus 6, because that was option 4. correct. Option 4 is minus 6. Let's type in minus 6 just to see what happens. So right here, here's that original line. And then here's x minus 6. So you can see it's on the bottom. So we moved down 6. So the question asks for which one moves up 6, and it would be option 3. All right. Here's, I guess, a fun way of doing this. And this is, like I said, if you watch the other video, it probably explains this better. But you have, or it'd probably be faster if you do it the way I explained in that video. But with a graphing calculator, you can type in these 4 different equations and see which one matches the graph that's there. So let's go ahead and show you how to type in absolute value, by the way. So let's go back to our y equals and clear these out. Now to type in absolute value, you're going to hit the math button and then arrow over to number. Right? On the top says NUM for number. And then the first option, ABS, stands for absolute value. If we hit that, we'll get absolute value bars. That's if you have one of the newer calculators. If you have one of the older calculators, it'll say ABS with parentheses, and basically those parentheses are going to act as your absolute value bars. All right, but we're going to type in, what are these equations? Let's do these, x minus 3 plus 2. So x minus 3. Now again, notice I'm inside the absolute value bar. If I want to get outside of it, I'll just arrow to the right, and now I'm outside the absolute value bar. If I want to get back inside, I would just arrow to the left, and back inside. But I'm going to go back outside. And then what was it again? Plus 2? All right, plus 2. Plus 2. If you want, here's what I'm going to do. I'm going to go ahead and just type in all 4 of these, and just remember that I typed them in this particular order. So the next one is absolute value of x plus 3 plus 2. It's probably smarter to do this one at a time, but I kind of want to just get them all done. All right, x minus 3 minus 2. Let's see here. Absolute value, x minus 3, get out of there, minus 2, and then the last one is minus 2 plus 3. Okay, so x minus 2 plus 3. All right, so I put them in the order that they're listed here. Minus 3 plus 2, plus 3 plus 2, minus 3, minus 2, and then minus 2 plus 3. All right, and when I graph them, it's going to graph them in that order as well. So I'm looking for the one that matches what I have to begin with. Which, the blue one actually looks like it's pretty close. It's definitely not the red one. The black one looks like it's a bit too low. And maybe it's the pink one. All right, so it's definitely not the red one or the black one because their points are in the wrong place. It looks to me, it's either the blue or the pink. The blue one looks like it's gone over 3 and up 2. And on this graph, it's gone over 3 and up 2. So it's definitely the blue graph, which is the graph that came first. And that is option 1, the x minus 3 plus 2. All right, so I'm going to go ahead and clear these off. Oops, I'm making a mess here. There we go. All right, let's go back to this. And what is the parent function of this graph? So it's not asking what is the equation for this graph. It just wants to know what type of function is it. If you want to know, basically, let's go ahead and plug in these in our calculator and see which one has that shape. We were looking for some kind of weird-looking arch to the right side shape. So let's type these in. I'll just do one at a time here, just to make this a little bit easier. The first one is the square root of x. So if we type in the square root of x, and we hit graph, what type of shape does this give us? All right, that looks very similar, doesn't it? So it's probably option 1, but let's just check the other options just to see what they look like. Well, let's keep that in mind. It probably is option 1. The cube root. So we hit math, and we'll get the cube root here, our 4th option. The cube root of x. Let's go ahead and graph that, see what that looks like. Okay, this kind of looks like a weird looking S, or like a sideways lightning bolt. It's definitely not what my graph looks like, so I would say it's probably not option 2. 1 over x, let's try what that looks like. Clear this. 1 over x is just 1 divided by x. That's all we really need. Graph it, and this looks definitely different than the one that I have, so it's not that one. Let's go ahead and try the last one. What was the last one? It's x squared. Well, we kind of already know what x squared is, right? X squared, it should look like a U shape. Yeah, all right, so I think process of elimination is definitely option 1. All right, and then of course we can graph this on our calculator and see which one matches the graph. So absolute value of x plus 2 plus 1. So let's go back. Let's clear this. And back to our absolute values. Remember the math button, the arrow over the number, and the first option. What was it again? X plus 2 plus 1. X plus 2 plus 1. All right, there it is. It looks kind of like option 1. All right, guys. I'm going to cut this video off here. Saves people on my door. This last one's just sort of which moves it left to right. Graph. You can graph all 5 of these and just see which one just moves the graph left and right. So this is where it starts, right? It starts at 0, 0. But you're looking for anything that's moved this point to the left or the right. You should have 2 options or 2 answers. We'll see you guys later.